What if the greatest threat of artificial intelligence isn't a sudden, dramatic rebellion, but a quiet, slow erosion of our own humanity? We often imagine AI risk as a singular event, a hard takeoff where machines suddenly outsmart us. But new research suggests the real danger is far more subtle, hiding in the math of our choices and the gradual loss of our decision-making power. Welcome to today's deep dive into the future of our species. In this video, we're unpacking a groundbreaking shift in how scientists view the existential risk of AI. We'll explore why the decision to accelerate AI development isn't as simple as good or bad, but depends entirely on the curvature of our economic values. We'll also uncover why the true risk in fields like healthcare isn't a sudden crash, but a slow buildup of overtrust. Stay until the end because understanding this distinction between decisive and accumulative risk might just change how you view every algorithm you interact with today. For years, the conversation around artificial intelligence has been dominated by fear of the unknown. Headlines warn us of superintelligent agents that could spell the end of humanity. Traditionally, researchers have framed this as the alignment problem. Can we reliably assign human objectives to these artificial agents? If we can't, the logic goes, we face an existential crisis. But here's the issue, this view has been too static. It treats risk as a fixed barrier, a wall we either hit or don't. It focuses on technical performance metrics, speed, accuracy, efficiency, while ignoring the deeper, structural values that drive our decisions. In healthcare, for instance, we've relied on static safety assessments, assuming that if an AI tool passes an initial check, it's safe forever. This approach misses the dynamic reality of how risks evolve. We've been looking for a singular tipping point, blind to the fact that the danger might actually be a slow, cumulative process that erodes our agency over time. The problem isn't just whether AI is capable, it's whether we are losing the authority to guide it. So, what did the latest wave of research reveal? It turns out, the path forward isn't binary. It's mathematical. Recent studies have identified that our optimal adoption rate of AI is contingent on the curvature of our utility function. Here's the breakdown. When researchers apply a log utility model, which reflects a high tolerance for risk in exchange for growth, the data supports accelerating AI development. In this view, accepting even a 1 in 3 chance of extinction is a worthy trade-off for the potential leap in human capability. However, when they apply a CRRA utility model, with a risk aversion coefficient where $gamma/Ject $2, the conclusion flips. This conservative framework dictates restraint. It suggests that unless an AI application specifically aims to extend life expectancy or solve mortality, the risks outweigh the benefits. Essentially, if AI is just optimizing consumption or convenience, a risk-averse society should hit the brakes. But if it's saving lives? The math justifies the gamble. Furthermore, the field is making a crucial distinction between two types of risk. First, there are decisive risks, high-stakes, singular choices where the outcome is immediate and clear. But second, and perhaps more dangerously, there are cumulative risks. These aren't sudden events, they are the result of incremental disempowerment. Think of it like water dripping on a stone. One drop does nothing. But over years, those drops carve a canyon. Similarly, the gradual integration of AI into our daily workflows slowly erodes human agency, often without us noticing until the control is already gone. In healthcare, this plays out through AI overtrust and goal misalignment. Researchers found that these operational flaws act as catalysts. A minor error in an algorithm, if trusted blindly, doesn't stay isolated. It compounds. It evolves from a manageable near-term